I'm Dallin, and I'll be talking about the difference between linear feet and square feet. Let's get to it. So, linear feet is a measurement of distance. Note, I don't say displacement because this is no displacement because I start and end at the same spot. But distance is the perimeter of this circle, because distance is a scalar quantity and can only be added up, whereas displacement is a vector quantity, and therefore can be negative or 0. Then area, and then square is a measure of area rather than distance. Suppose we have, let's say this is 1 linear foot. I know this isn't actually a foot. This is closer to an inch, but let's call it a foot. This is 1 linear foot. Then a square foot is defined as the area enclosed by a square with each edge 1 foot. So this would be a square foot. Let's say it's 2 linear feet. Let's form a square out of that. Note, this isn't 2 square feet. As in fact, it is 4 square feet. Reason why is the area of a square is given by the edge length squared. So the area of a square with edge length 1 linear foot would be 1 squared equals 1 times 1 equals 1. And this one has area 2 squared because its edge length is 2 linear feet equal 2 times 2, and that equals 4. So we have 3, that would be 3 squared equals 3 times 3. This can be applied to more dimensions as well. Let's say we have a cubic foot. Let's pretend there's a line here, another line here, another line here. And that's a measure of volume. If you decide to do an edge length of 2 instead of 1, we have 1, 2. So we have 1, 2, 3, 4, and then the next level, 5, 6, 7, 8. And that follows the same rule. 2 cubed equals 2 times 2 times 2 equals 4 times 2 equals 8. And linear feet is also often to designate the perimeter of an object. Like, for example, the perimeter of this is 8. Because 1, 2, 3, 4, 5, 6, 7, 8. And so the linear feet of this would be 8, where the square feet would be 4. The linear feet of a square is the edge length times 4. So, 1 times 4 equals 4. 2 times 4 equals 8. 3 times 4 equals 12. And as you can see, these are different. In fact, you can actually have objects like this, except that objects that have the same area as this, but a different linear feet. Like, for example, we could have a circle has, the circle would have area 4. And so if the area is 4, then that would be equal to pi times the radius squared. The formula for the area of a circle. And so we solve for r, we get 4 over pi equals r squared. So r equals 2 over the square root of pi. Or if you want to rationalize the denominator, you can get 2 square root of pi over pi. And the circumference of a circle is given by pi, 2 pi times the radius. If you're used to pi times the diameter, that's because the diameter is 2 times the radius. So applying 2 pi times the radius to this, substitute r, we get 2 times pi times 2 times the square root of pi over pi. That simplifies to 4 times the square root of pi, which is different from 8. Pi is, and the square root of pi is in fact smaller than 2 because pi is smaller than 4. And so this has a smaller perimeter than this. In fact, the circle is the most efficient shape in terms of perimeter, in terms of the ratio between perimeter and area. The least efficient shape is the fractal. You can form a fractal by starting with the triangle, then each successive, and you put a triangle on each side. Then things get really complicated quickly. And then you do this an infinite number of times. To show this would require calculus, so I'm not going to prove it, but if you do this in an infinite amount of time, the fractal will have a finite area, but it will in fact have an infinite perimeter. The perimeter would not be a number like 4, 8, or 12, but it would in fact be infinity. And you can see linear feet and square feet are different.